Assalamualaikum. My name is
Based on the experiment that we
Fatihani,
have
and I will
conducted,
explain more details
oil
about
viscosity,
the metric.
I've been painting every fence I know.
Hello, Assalamualaikum. So today my group will present to you about the lab kinematic viscosity. So the introduction part, I will tell to you about that. Okay, for kinematic viscosity, it's usually known as dynamic or absolute viscosity. Okay, it can be decreased or increased, depends on the result of the oils. It's such as will be contamination, fulmination, or shear tanning. Okay, so measurement of viscosity is extremely important for gear oil, fuel oils, engine oils, and hydraulic oils. Okay, so for the viscosity also can be determined by measuring the force that required to overcome the fluid friction of the known dimension. Okay, the viscosity of different oils varies at different rate temperature, which is in engineering application. The viscosity is usually chosen to be at the performance at the optimal performance within the required temperature. Okay, so for the dependency of oil, it can be determined by calculating the kinematic the viscosity index. Okay, so it is an empirical parameter that compares the kinematic viscosity of different sensitivity of viscosity in temperature.
Assalamualaikum. My name is Muhammad Syafiq Muhammad Khairi. I will be explaining regarding the justification of solution of our assignment. So our assignment is to demonstrate the analysis of kinematic viscosity of different grade oil. Our assignment, the first objective is to understand kinematic viscosity measurement method by using heated viscometer. So the heated viscometer is suitable for testing viscosity of both residual fuel and lube oil from a wide variety of applications, including diesel engines, gas, and aviation turbines. Testing viscosity of fuel oil is important for verifying the correct grade of fuel delivered, for calculating combustion performance, plus adjusting of fuel handling and injection system. Viscosity of lube oil is the most important property, with the correct viscosity providing optimum film strength and system clearance with minimum friction losses and leakage. For our second objective of our assignment is to determine the viscosity index of lubricant. From the data obtained that we got from the heated viscometer, we will be calculate the viscosity index for each of the sample used in this assignment. We use three different grade oil in this assignment, which are SAE 20, SAE 30, and SAE 50. There are another two samples that are contaminated with water. For this sample, we use SAE 50 but with different percent of water contaminated. There are 0.5% and 2%. So for the third objective, we can understand the grade of oil based on the viscosity obtained.
Assalamualaikum. My name is Fatihani, and I will explain more detail about the method to do this kinematic viscosity oil analysis. There are two parts of this method, which is part A. We will start with oil filling. First, as in the poster state as hold viscometer, which is the viscometer must hold vertically and slacken blade valve, and then the sliding was pulled out, and then clean the viscosity tube and steel ball must be cleaned before start any other process to clean the ball and the tube from other oil sample before this we use, and then we put the ball back inside the viscosity tube, and then we fill the viscosity tube with the oil sample that uh, we would like to analysis or to test, and then must beware to not above the V plate, and must pour the oil below the V plate, and then the blade valve was loosely fit, and the valve open was slowly pushed in and rotate the plug to let the oil bleed until all air is expelled, and then fully tight the bleed valve and wipe out the excess oil from the plug. And then the viscometer was placed back on the base, and the power cable was connected, and then the viscometer now ready for use, but cannot chill yet because the yellow power supply lead was connected to the viscometer and locked into place by rotating the outer collar, and then the main lead was connected into the socket on the inside of the power supply. Select the correct main voltage before start, and then the other end of the lead was plugged into the main supply, and then lastly the main power was turned on, and then turn on the power supply too. And next is part B, which is we use it for measurement of viscosity by holding the viscometer. First, only we need to fill the oil sample in the viscometer as we did in part A, and then the density was selected by key-in density of the sample. For this experiment, we use 40 degrees Celsius, and the temperature required was selected with the return key, and then the temperature display flash as the viscometer hit the oil, and let the degrees symbol flash until the oil temperature stabilize, and then wait for viscometer display 40, and then when the oil temperature is stable, the display will show viscosity at the 40 degrees as selected, and then the value of corrected viscosity at 40 degree and 100 degrees Celsius will be recorded, and then use a arrow key to toggle display of viscosity from 40 degrees Celsius to 100 degrees Celsius, and wait for the display, and then probe before taking repeating reading, and then lastly the process of part A and part B will be repeat to do another sample or sample type. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Firdaus Hashim. For my part, I will be explaining about the result and the discussion. For first, let's we go to the result first. For the result, as you can see, we will determine the viscosity index. So the viscosity index is determined by measuring a fluid kinematic viscosity at 40 degrees Celsius and 100 degrees Celsius. The data is obtained from the experiment by using the Kittiwake viscometer on different grades of oil. So we will be using the formula given in NSTM SMTND 2270 to determine the viscosity index of oils. So let's see, we here the viscosity index formula is given by VI, and VI as is unit equal to L minus U divided by L minus H multiplied by 100. So VI stands for viscosity index, U for kinematic viscosity of the oil at 40 degree Celsius, L stand for kinematic viscosity at 100 degree of the standard oil of the index obtained from the appendix 1, and H kinematic viscosity at 100 degrees Celsius at standard oil of the index. So we obtain it from the appendix. So let's see here. We have the result that we have obtained. So the result in the table is obtained by following the procedure above. Okay. As our members Nani have present. So we have here we have like 5 sample. For first we have SAE 20, 5 weather 30. Second we have SAE 30. Third we have SAE 50. 5 we have SAE 50, 0.5% water, and last but not least SAE 50, 2.0% with water. Okay. As we can see at temperature 40 degree Celsius, okay, the average is around like 60 and above, and so it will be more slower, okay. But for 100 degree, we see its kinematic viscosity is lower. So which mean the oil become more the oil become less viscosity, so it will transfer more easily lah. Okay, so I will take one example to calculate the index viscosity. So we'll take SAE 35 with the 30. Okay, firstly we will using the formula V viscosity index. Okay, first we need to find the L and H needs to be found. L and H need to be found in the appendix 1. So let's see for the sample, we know that the kinematic viscosity at first to refer the table, we need to find the kinematic viscosity at 100. Okay, so we know that the viscosity at 100 for SAE 20, 5 weather 30 is around 8.45. But if we refer in the table, you see that there is no 8.45. We have 8.40 and 8.50. So it's between them lah. Okay, how can we determine its L and H? Which their kinematic viscosity at 100 degrees Celsius. We will be determined by using interpolation. So by doing interpolation, we get that its L is 100 and 110 and 110.35, and H is 64.75. Okay, from that we have known the L and H, so we will put into the formula and we get around 99.59%. So it's quite better because for mineral oils, it's good viscosity index is around above 90 to 120. That's all for the result. And we move to the discussion. So in this discussion part, we will explaining about the first is oil viscosity to its type and grade. Second, to the effect of the different engine oil grade to performance of engine performance. Third, the effect of the wrong grade used to an engine. Fourth, the effect of water contamination to viscosity. And five, the effect of water contamination to circulation of lubricant oil. So we will go through one by one. Okay, first we see the oil viscosity to its type and grade. Based on the experiment we have conducted, the oil viscosity varies based on its type and grade. Engine oil viscosity refers to how easily it will pour at a specific temperature. Low viscosity oil pour more easily at low temperature than thicker oil that have a higher viscosity. So viscosity of oil notated using the common classification. We have XW dash XX. So X represent the number and W is represent for its weather. The number before W show the viscosity of the oil at 0 degree Fahrenheit, in bracket 7.8 degrees Celsius. The lower the number, the thinner the oil in cool weather. The number after the W shows the viscosity of the oil at 100 degrees Celsius and represent the resistance of the oil to thinning at high temperature. So point number 3 is the effect of wrong oil grade used to an engine. Using the wrong oil can lead to reduced lubrication and shorten engine life. If the manual says to use synthetic oil, do so. Contrary to what some believe, adding synthetic oil to regular oil won't harm the engine, but there is also no benefit in doing so. Use only what the owner manual specifies. And the number 4 and 5 we will combine. Based on the result above, we can see that the water combination change the viscosity of the oil. The more the water present in the oil, the thicker the oil viscosity. This can affect the circulation of lubricant oil. As the oil become thicker, it's harder for it to flow. It also can cause blockage throughout the engine lubrication system and make the operation become unsuccessfully.